So in this video, I'm going to talk about current and voltage. This is going to follow on from my previous video about electrical circuits, and last time I looked at circuit symbols. So this is going to follow on directly from there. So I'm going to start off by talking about current. So current is a flow of charge or electrons, and it's measured in amps. So we measure it in amps. So basically, the current is a measure of how quickly electrons are flowing around the circuit. So I'll talk about that more in a minute. And then the other thing we'll talk about is voltage, which is a measure of potential difference, and it's measured in volts. Now, potential difference is sort of like an amount of energy. So the more voltage you have, basically, the more force there is to push the electrons around the circuit. So I'm going to use some of the circuit constructor kits from FET to demonstrate how this works. So this you can get from FET. So if you search for FET, which is P-H-E-T, just search for that and then Circuit Construction Kit, and you'll be able to find this, which is an excellent way of making circuits. So I'm going to explain to you a little bit how this works. So when you load it up, if you open up the lab, you will get this. So there's components over here which I can drag on as I need. So I can take a battery, I can take a wire, and then I can join them up how I want. So I can take a light bulb, and then I can connect the wires to the light bulb like that. Okay, so there's one that I've done earlier down here, and also I can click here, show current, and then I will see that there's electrons in my circuit here. So here I've got a switch. If I connect the switch, then I can see that the electrons will start to go around the circuit, and this is indicating that the light has lit up. So these electrons here are flowing around the circuit. They're going from the negative side all the way around to the positive side. As they pass through the lamp, they will cause the lamp to light up. So this flow of these electrons here is the current. Now, over here, I can have, if I just stop that a second, I can disconnect these bits of wire here, actually, and I can replace this with an ammeter. Now, an ammeter is something which measures the current. So what it does is effectively it counts the number of electrons that are going past in a certain time. The more electrons that flow past per second, the higher the current is going to be. So in order to measure the current in the circuit, I would need to place the ammeter in series, so basically in place of part of the wire, and then so as the electrons flow through the ammeter, it will be able to count them. So now if I reconnect the circuit, I should be able to see that the current here is reading 0.9 amps. So that is a measure of how quickly these electrons are flowing through. Now, I said that voltage would be a measure of how much force and how much energy it would give. So here it says voltage of 9 volts. If I was to increase the voltage, I basically would give the electrons more of a push as they go around. So by increasing the voltage, I was able to push the electrons harder. You can see this is now showing that the light has lit up more strongly. And you can see here that my current has increased. If I turn the voltage back down again, then you can see that the electrons will go more slowly and the current would reduce again. So that's basically how the idea works. So the idea of voltage is it pushes the electrons around the circuit, and then the current counts how quickly they're going past. So what I've made here, first of all, is just a very simple series circuit. So I said before that series is where there's just one loop. There's only one way for the electrons to go. So on another page here, I've made a couple of other circuits. So this one at the top here is similar to one I talked about in the last video. So I've got here one battery. Also, if you want, you can change here and it will change it to the circuit symbols. So this is a symbol for a battery. The symbol they've used for the light bulb is a little bit different to the one I used. It's just got a little loop in it instead of a cross, but it's the same idea. Battery, and then you can see the electrons are here as well. I actually prefer this one. I think it's easier to see, so I'll switch back to that. But it is possible to use the symbols. Here we've got a switch, here we've got a switch, here we've got a switch. So in this circuit here, I've got two light bulbs and I've got one switch. If I close the switch again, you can see now that the electrons are going around the circuit again. Around here, from the negative, electrons flow around the circuit, through this light bulb, and back to here. Now, compared to the previous circuit, you should notice that the electrons are going more slowly and that the lights are not lit up as much. The reason for this is because it's now more difficult for the electrons to get pushed through these two lights. So because there's more what's called resistance, to make it harder for the electrons to get through, they're going more slowly. So the light bulbs don't light up so much. Now, when I had an ammeter, and I put it in part of the circuit here. There's also an ammeter, which is sort of a cheat ammeter, but you can just take it and you can just pop it over the top of the wire and it will tell you what the current is at that point. So here, current is reading is 0.45. Since the electrons have got nowhere to go, they only go around in this one single loop. Wherever I put the ammeter, it will read 0.45 all the time. Everywhere. Now I haven't got it on top. I can't get it up there. Okay. But it would also read 0.45 there. So wherever I put it, it's going to read 0.45. If I wanted to increase the current, again, I could change the voltage on my battery. I can increase the voltage here. So it was 9 volts. If I make it 18, like that, then it should have doubled the current because I've increased the voltage twice as much. So I should have returned the current to 0.9, which I have. So you can see the electrons are now moving faster, lights have lit up more, and my current has now increased to 0.9. This one again is a series circuit because I've got all the electrons just going around in one single loop. Now the circuit I've made at the bottom is slightly different. This one's got one battery, it's got 2 lamps again, but this time it's got 2 switches. So here we've got the possibility of having 2 separate loops. So I can close this switch at the top here, and I've got a loop of my electrons going around in this loop. I can open that switch, close this one, and then I've got my electrons going around in this other loop. So this circuit here is called a parallel circuit because I've got 2 possible parallel loops. So this circuit here will go around. If I put my ammeter over it, I've got 0.9, 0.9, 0.9 anywhere. So while that switch is open, I've basically just got one single loop and it's as if the other part wasn't there. Okay, if I open that one, close that one, I would now have the same thing but 0.9 here. Okay, now in this case, we've got the possibility of actually running both the lamps at the same time. So if I close both the switches, both the lamps have now come on. So you may have noticed in the animation, when I did that, the electrons up here will have sped up. We've still got 0.9 along here, 0.9 along here. But if you look closely at this point here, you should see the electrons are coming down, and in this junction, one electron goes to the right, the next one goes straight down. One goes to the right, one goes straight down. One goes to the right, one goes straight down. So what's happening here is the current is dividing up. Half of the current is going along this way. The other half of the current is going along this way. So along here I had 0.9, basically counting the number of electrons which are going past, which is measure the current. Down here I've got 0.9. So up here I should have double that. I should have 1.8. If I take my ammeter and put it over here, I can see it is indeed 1.8 because I've got double the number of electrons here because half of them have to go that way, half of them have to go that way. If I look over here at this junction, you can see that the electrons from this way and the electrons of this way are coming, and both of them together are going up this way. So over here, I should also have 1.8. Now, it would also be possible, just because of the way the circuit works, if I was to disconnect this one here a second, and if I was to put a switch in up here, this switch, because it's in the part of the circuit which controls both of the lamps, if I have it like that, this switch will turn on both the lamps together and off, both of them and off. Because in this top part of the circuit, the whole of the current has to go through here. So if I break it, then I don't have a complete loop anywhere. There's no way for the electrons to get from this side of the battery to this side if this switch is open. So in order to have a complete circuit, I have to be able to get from one side of the battery to the other side. The electrons have to be able to reach all the way through. If I was to just open one switch, they can still get there from this way around here and back up to here. Now, you might also notice that in this circuit, compared to the top one, if I turn this battery back to, this was originally 9 volts, wasn't it? Like that. Okay, so the voltage and the batteries are both the same. They're both 9 volts now. If we look at the bottom circuit, you can notice that the lights are both equally bright, whereas on this top circuit, the lights are half the brightness. The reason for this is that the electrons here have to go through this lamp and then through this lamp. So it's the same part of the circuit. The electrons have to go, whichever way they go, they have to go through both of the lamps. So it's therefore twice as difficult. In this circuit, the electrons can go this way, only have to go through one, or they can go this way, they only have to go through one. So in this way, it's easier for the electrons to just go through one lamp. So that's why in this circuit, the current is 0.9 here. Current is 0.9 here. Whereas in this one, the current is 0.45 because it's harder for electrons to get through both parts of the circuit. So I shall talk next time about resistance, and we'll be able to talk about how we can calculate using the voltage and the resistance what the current is, and why it is that these lamps are dimmer and these ones are brighter. But we should have an overview here of how electric current works. So current is a flow of electrons from the negative round to the positive. And the voltage is the amount of energy supplied by the battery, how much push there is to push the electrons. If I give more voltage, then the electrons will get pushed harder and they will move faster and the lights will turn on brighter. So if you want to have a go and play with this, then if you search for PhET labs, then you can find this and you can play with it for yourself.